Hello everyone and welcome. In this video I want to cover how you can use analytics with TabJolt to try to figure out what configuration works best for your server. There are many use cases of TabJolt, and if you're not familiar with TabJolt, I encourage you to review the videos that I posted earlier on TabJolt. At a high level, it's really a load and performance testing tool that we built in-house in Tableau, and we're making it available to our customers and partners. As I thought about how I should present this, the primary goal is to really show you how you can do analytics with the workbook that's included in the TabJolt download. So I thought, what kind of a configuration would work best for my Tableau server running on my Windows Parallel VM? I wanted to maximize throughput, but also have a reasonable average latency of 4 seconds or less, with a not too bad an error rate, say like 5%, given my specific hardware constraints here. And given I'm running everything on the laptop, my install basically had one server process of each type, one BizQL process, one data server, one data engine, etc. With the exception of cache server where I had two of those. So your default Tableau server installation when you do your own tests may vary. So what I did is I ran a 10 user load using TabJolt on my laptop and worked through various configurations for the server to figure out which one works best. But I recommend you don't try this at home because really my machine is not a server class machine. I'm running this on a MacBook Pro with 4 cores and 16 GB, and it's running Windows 7 Service Pack 1, 4 cores and 8 GB RAM on the VM itself. Right, so your Tableau server deployment out of the box installs a specific set or number of server processes, which may or may not work for you depending on your workload, your environment, your hardware, etc. So the purposes of this demo, I used the 2013 annual sales growth sample workbook as my workload. Now, when you use TabJolt, you can use your own workbooks that you have, but I highly recommend that you consider optimizing your workbook. Make sure you run a single user load on your workbook and see how that performs. So when I ran a 10 user load, I saw the first run was not too bad. So here I'm looking at the key performance indicators worksheet that comes with the TabJolt Analytics workbook. At the top, you see the run description, some details about the owner of the run, the start and the end time for the run itself. And then as I scroll down, you see that I have some of the key metrics here already captured, the average response time in milliseconds, tests per minute, which is really a throughput, and then the error rate as well. So in this particular case, which is my baseline, I had one BizQL server, two cache servers, and one background server, and one of every other server process I had mentioned earlier. So I'm looking at an average success TPS of 2.05 with an average response time of 4.89 seconds. Well, that wasn't too bad, but I thought let's experiment. So after the first run with one BizQL and two cache servers, I decided to double it and see what happens. So here's the configuration of the server on my laptop once I doubled the number of BizQL and the cache servers from where I had it at the beginning. So I doubled the configuration, started the load test with TabJolt, the same load test as before against the same workbook, and I went off to bring a cup of coffee. But by the time I got my coffee back, I was sitting at this particular message on my laptop, my Windows Parallels VM. Your system is low on memory and you may see decreased performance. Please try closing some applications. Well, that wasn't that great news for my particular test that I was running. But I thought, let me take a look at what's actually going on with the server. So with the resource reaching threshold, the server processes that are critical, like BizQL server, for example, has built-in threshold monitoring. And in this case, as I ran the load test, when resources become very sparse, BizQL decided to restart itself. And here in this case, I see that BizQL server went down, the BizQL server came back up again. If I'd let the test continue, it would probably have continued to work through it and then would have seen more iterations of this. But clearly, BizQL server is trying to manage its own health even in a resource strap environment. And let's see what the data showed me. So here, I'm comparing the first baseline, one BizQL, two cache servers, one background server, with 2 SQL servers, 4 cache servers, which is the scenario where I doubled it, and then the same one backgrounder. So here I got better average response time this iteration compared to the baseline. And also throughput was better as well. But if I look at what happened during the run, I see that for the run where I had 2 SQL servers and 4 cache servers, and I saw the SQL server restart through the test, I saw that around minute 7, I started to see the average response time going up. I noticed that the throughput, or test per seconds, is coming down, and also the number of errors is going up during the test as well. So I got wondering, well, what that might be. Clearly, I know that SQL Server restarted, but I wanted to do a little bit more. TabJolt captures a lot of information behind the scenes as well to help you triage issues as you're running through load. So when I look at the test failures worksheet in the TabJolt Performance Analytics workbook, I can look at the error rates, and as I look at the error rates, I can also specifically look at the test name, in this particular case, the InteractViz test, and the events that actually occurred during the test and what was going on. So as I select these events, I could then go down at the bottom, look at the specific test failure details. And here in this case, I see that there was a socket timeout exception, read timed out. Well, that's not a surprise given SQL Server went through a restart. So that's expected. But I wanted to learn more and find out a little bit more about this. TabJolt also allows you to drill down into the tests themselves. So here what you're looking at is that's the first baseline test, and this is the second. 32 is the test run ID. 32 is the second test that we just completed. So in the second test, you see that TabJolt is showing you that there were some errors at the top, and when I click on those, TabJolt is now showing me the hierarchy of the requests. So here, the top level test here in this particular case was the InteractViz test. Now that particular test actually had specific test steps that were executed as part of it. So here when I look at the highlighted requests, these are all the sub requests that happened as part of the parent request up at the top. So when I look at one of the sub requests, here's what's going on, where in this particular case, optional, so view session came back with an error. Now, if I look at some of the other ones here, there was a bootstrap request that failed as well. So TabJolt is giving me a little bit more detail about what is going on under the hood so that I can make better decisions about my test and load testing strategy and inform my load test plan so that I can best fit the needs and the goals that I had set out earlier. So with SQL Server restarting, if I looked at the system metrics, which is another thing TabJolt will give you, is look at specific metrics for both the system as well as specific components within Tableau Server. So the SQL worksheet in TabJolt Analytics gives you an idea of specific JMX metrics and system metrics for the SQL Server process. So here you're looking at percent processor time in the working set for both the tests and also the iterations. So here the red one is the first test that I did with one SQL server. In the second test, I had 2 SQL servers, and it's showing me both the SQL servers and the associated metric for that. So very useful when you're analyzing load test results and performance results as well. But overall, again, back to my goal, I wanted to scale better. I wanted to find extra memory so I can find the best configuration for my laptop. So I went and scaled down, and I said I wanted to reduce the number of cache servers, right? Only a single box, not a lot of workload, so maybe one cache server will do for this particular configuration. So I went through and I reduced the number of cache servers to 1. I reduced the backgrounders to 0 because I didn't really care about subscriptions or extracts in this particular case, and 2 SQL servers. So here's my server configuration, and the status for the server was up and running, and then I went through the same test one more time. So as I iterated, one of the things TabJolt is allowing me to do is do a run-to-run comparison. You notice that I run through each one of those configurations and come back and look at the key performance indicators as one of the first things. And looking at both the average response times in tests per minute and also the error rate and comparing them side by side. So here in this particular case, if I look at run ID 37, that's my latest run, which is the bottom, I'm seeing a much better average response time compared to the previous iteration, or the baseline, excuse me. And then also the throughput was significantly higher compared to the baseline as well. So looking at specific numbers, here's the success TPS for 2 VisQLs, 1 cache server for my box, and here is the average response time. I'm seeing an improved throughput and also response time with 2 VisQL servers, 1 cache server, and no backgrounders. And if I look at the system utilization, seems like overall for this particular condition, my system's better utilized as well. Okay. So what trade-offs did I make, right? So here's my final choice for my laptop. Again, the laptop with 4 cores and 8 GB of RAM, pretty meagerly set up from a resources perspective by design, in really the context of showing you some of the capabilities with VisQL resource monitoring and the TabJolt analytics itself. So I made a bunch of trade-offs as I went through this process. And clearly, this is a very risky configuration for any production level Tableau server deployment. What I did trade off is I have no redundancy except in VisQL server, right? So I have one server process, one of every server process, except VisQL where I had 2 of them. So if any one of the server processes went down, like the application server, for example, server won't be available. I'm not running in the high availability mode because I have no passive repository in my deployment. 2 VisQLs and 2 cache servers was worse than 2 VisQLs plus 1 cache server for this particular test. But if my went load beyond 10, lack of cache servers is likely going to impact me. But clearly on this hardware, I cannot run more than 1 cache server given the TPS and the average response time expectations I had based on the goals. I chose to eliminate the backgrounder as well. Now, this doesn't mean that you should do it. It just means that in my case, because I didn't really have any subscriptions or extract refreshes going on at the same time, I felt that I really didn't need that particular process to do to consume more of the resources where I have a machine that's resource strapped already. And primarily, I made a lot of these trade-offs because what I really wanted to show you is one particular use case of TabJolt where you can iteratively test various server configurations to find the one that works best for you in your environment. Right, and really do try this. While I was not kidding earlier when I said don't do this at home with the kind of hardware I have, uh, please do try TabJolt and see how it works for you guys. TabJolt can be a powerful tool if used right. You can try it when you're installing a brand new 9.0 Tableau server and want to understand how server scales for you. If you're upgrading and want to understand how your existing workload that goes against 8.x goes against 9.0, that's a great use case as well. In addition, you can find, like we saw in this example, the best configuration, deployment configuration for the number of processes you should run. And also, oftentimes, customers want to do a load of performance test before they go live in production. And TabJolt, because it doesn't require you to record and replay and maintain scripts, it's essentially a point and run tool, will allow you to accelerate that process as well. We'd love to hear from you. If you have comments or suggestions, please tweet me at Nilesh Kamkol and also watch the other videos that we posted earlier on just getting an overview of what TabJolt is and also how you can get started, which includes a step-by-step process of how you can download and get TabJolt running in your environment. Well, all the best. Thank you for watching. I hope you enjoy TabJolt.